How are you, my friends? In this video, I'm continuing the Algebra Course lectures, lecture number 24, other types of equations. If you want to see the other lectures, please, you can go and visit the Algebra Course lectures. Now, the objectives here, we have three types. Type number 1, 2, and 3, we will study in this lecture. Polynomial equations, radicals, and then quadratic type, the most important one. Let's see, just to remind you that we have studied some equations. I will put the name here, linear equations. You can see that this is one example here, and the solution, you can see that in lecture number 16. Rational equations, that's one example here. Solution is there. You can go to lecture 16, you see more examples. Power equations, this is one example. This is the solution. This is lecture 17. And quadratic equations, this is one example. This is the solution, lecture 22. Let's start. Type number 1. A polynomial equations, when we need to solve these equations, we have to rearrange the equation first. It is a must. Put all the terms must be equal to 0. And then, like this example here, x power 4 is equal to 16. Take 16 on the other side, factor it, x squared minus 4, x squared plus 4. We can factor more here, x minus 2, x plus 2. Now, in the real numbers, we cannot factor this, x squared plus 4. There is no real number there. So if we ask for the real solutions, we say real solutions are 2 and minus 2. If we need to go further, there are two complex solutions here, non-real. You can factor x squared plus 4 as x minus 2i, x plus 2i, sum of two squares. We have seen in the complex numbers there. So if we say find all the solutions, there are 2 minus 2, 2i minus 2i. Nice and easy. Let's see, example 1. This is a polynomial equation of degree 5. X power 5 is equal to 9x cubed. Now, many students I have seen, they divide by x cubed, which is wrong. Why wrong? Because we are losing solutions here. If you divide by x cubed, you get only x squared is equal to 9. Although we have x to the power 5, so that means there are 5 solutions. Some of them might be repeated. So put all the terms equal to 0, like this one here. Factor it, x cubed out, x squared minus 9. Difference between two squares. So x cubed is equal to 0. That means we have one x is equal to 0, another x is equal to 0, another x is equal to 0, repeated 3 times. X will be 3 or minus 3. When we write the solution set, we write only 0, 3, minus 3. But we know that there are 5 solutions, 3 repeated, the same number 0. Let's see more nice question here. Let's solve the polynomial equation. X cubed, all this is equal to 12. One big mistake I have seen from students, if they take a common factor x, that's wrong here to take a common factor x, because you should have 0 on the right side to factor the equation. So be careful. So put all the terms on one side equal to 0. Since we have 4 terms, we can use grouping. Factoring by grouping. Take the first 2 terms, the last 2 terms. There is a common factor here, x squared. Here there's a common factor minus 4. And then you proceed on, so easy. You find the solutions 2, minus 2, and minus 3. Once you know the idea, you can proceed. Type number 2, we have radicals. It can be square root, the index 2. It can be cube root, the index 3, etc. So the idea here, we have 6 steps, easy steps. You don't have to memorize all these steps, but you have to know that isolate a radical on one side, put it on one side. If it is a square root, you square both sides. If it is cube root, you cube both sides, and then you remove one radical from the way. Then you continue combining like terms. Sometimes you have to repeat the steps. until you find the solution. Now, if you have a square root, like the index is 2 or 4 even, you have to check your solution. Just a done example, very simple, easy before we start. Square root of x plus 1 and minus 5 is equal to minus 2. We need, remember, to isolate the radical. So take minus 5 and the other side becomes 3. Square both sides now. So x plus 1, when you square it with the radical, you get x plus 1. Square the 3, 9. Take 1 on the other side, x will be 8. Not enough to stop here, guys. You must check. You have to check. Check means take this value and replace it in the original equation. Make sure the right side is equal to the left side. So it checks. After that, you write the solution set is 8. Suppose this one does not check. Maybe you get 0 equals 7. So not true, like false statement. You say no solution. Now, two simple equations first, then we go to another example with more higher level. Square root of this plus x is equal to 0. What can we do? You can try it if you like, but for sure we have to isolate. This is a radical, there is x here only, equal to 0. Even if we have a number here, 5 or 2 or 1, whatever, take the x on the other side, and then we square both sides. See, we take the x now, becomes minus x. Remember here, be careful. Now you square both sides. This one, we remove the square because power half. So I have x squared plus 5x plus 10. Minus x all squared is x squared. It happened now, these are canceled. See, we are left with only 5x plus 10 is equal to 0, so x will be minus 2. Now, sometimes they're not canceled, so you keep it as we will see in the next example. Remember, squaring here, the index is even 2, you have to check. Now it's okay now, so the solution is minus 2. Now the second one, cube root. Cube root, isolate, rearrange it, take this on the other side, cube both sides, see all the side, put the whole bracket, cubed. Now this becomes, this one is equal to x. See, we have now the squared here. So that's a quadratic equation. We can just normally factor it. If it happened that you cannot factor, you can use quadratic formula, which you know in lecture 22. So x will be 1 over 4 or x will be 1. We don't have to check here because the index here is odd. Cube root, any number we can accept, positive or negative under the radical. So the solution will be 1 over 4 and 1. Let's see the nice question here, very important question. Find the sum of all the solutions of this equation. We have two radicals. This is a little long. I would not say complicated. It is a little long. Since we have two radicals, you have just to imagine that you have to square both sides somewhere on the way 2 times. So first let's isolate here this one. Take this one on this side, leave the first one. So I take minus square root of x plus 2 on the other side here. So you move one radical to the right. Square both sides. Please write all this bracket, square it. So let's expand now. This one is easy, it will be 2x minus 3, but this one is not easy. Look at this formula here, waiting for you. A plus b squared, we know a squared plus 2ab plus b squared. Just apply it now. Don't forget the middle term, 2ab. Many students, they forget 2ab. They will never reach. Now, when you simplify this, this is x plus 2, and the sum squared is 1. Rearrange again. All this equation, you have to rearrange it until you reach, you can check it please, x minus 6, 2 square root of x plus 2. Square again, and we know that. Square again, because we have to remove these radical here. So you square all the side. You see all the bracket. Now this is easy. When you square this, you get 4. See the 2 outside now, 4. And this is x plus 2 in the bracket. This one, x minus 6. Also, please do not forget the middle term. So that's use this one here, a minus b squared. This is the sister of this one here, a plus b squared. Okay, a squared minus 2ab plus b squared. Now rearrange the equation. We continue in the next slide until we get the final equation is this one here. Look at this quadratic. X squared minus 16x plus 28 is equal to 0. Please, you can pause the video anytime and then check all these numbers. Now when you factor it, x minus 14, x minus 2. Two solutions we see. Both of them are positive. Both of them are nice. But look at the question here. Find the sum of all the solutions. Find the sum. So that means you add all the solutions. If you add 14 and 2 and you answer the sum is 16, that is wrong, unfortunately, because you have to check. Check means take 14 in the original equation, you will get 1 equals to 1. Take 2 in the original equation, you get minus 1 is equal to 1, which is wrong. So x equals 2 is rejected. So the only solution is 14. The solution set is 14. The sum is 14. Only 14 for this nice question. Now, type number 3. The equations are called quadratic in form or quadratic in shape. These are little tricky, guys. I put here on this slide, I put one example here. You can see, I will explain now in details. This is x power 4 minus 11x squared plus 2 is equal to 0. That's one example. This is another example. This is number 2, number 3, number 4, number 5. So there are 5 examples in this slide. All of them, the same idea. Now, if you look here, I will explain the meaning of quadratic in form or quadratic in shape. If you look at this one here, 12 x power 4 minus 11 x squared plus 2 is equal to 0. Can we say it looks like quadratic? And the answer is yes, but it is not quadratic. So these equations, now we're talking about here, type number 3, they look like quadratics, but they are not. Because at least this is power 4, so we have 4 solutions. But the quadratic itself has only 2 solutions. Now, the last question now, how do we know that these equations are quadratic in form? If one power is half the other power, see here we have power 4, power 2. Okay, one of them is half. Here we have power minus 4, minus 2. One of them is half. Here we have 2 over 3, 1 over 3. Here we have minus 2 and minus 1. But if we have here 4, x power 4, x cubed, this is not quadratic in form. So we have to use other methods. Now, usually we say here, we change the variable. We take the smaller power with the x here, x squared, and we say let n is equal to that. You square both sides. Then the equation becomes 12n squared minus 11n plus 2, which is quadratic. Now I will explain this in details in this example here. 12, same example, guys, same numbers. 12 x power 4 minus 11 x squared is equal to minus 2. Let's solve this equation. Now by looking, you have to say, at least you have to say x power 4 means we are waiting for 4 solutions. Second, you say it looks like quadratic. So let's rearrange it. Never take a common factor here, I said. If you have a number there, it should be 0 on the right side. So bring the 2 there, minus 2 becomes plus 2, equal to 0, and then let, you see this, look at this blue here, oh boy. Let n, I take the smaller power, x squared. Now I put this in details here for you. Square this one, you get n squared. Square this one, you get x power 4. See, I change now this equation from x power 4 to quadratic. This is quadratic in n. Now, easy now to factor it. Quadratic, you know, we have, sorry, we have 4 ways we can solve. One way, easy way, is factoring. If you cannot factor, use quadratic formula. So 3n minus 2, 4n minus 1. So n will be 2 over 3 or n will be 1 over 4. Remember, there is no n in the question. See, this is our question here. Only x. So always you have to go back to x. You see this one here? Back to x. Remember that. It comes directly with let n. If you don't like n, you can put y or k or whatever, d, c, e, etc. Let's continue in the next slide. So this is n equals 2 over 3 or n equals 1 over 4. Remember, this is what we used for let n is equal x squared. So n 2 over 3, I replace it there, so I get x squared equals 2 over 3. That's another simple, easy, tiny quadratic equation. We can find the x by taking the square root of both sides, little rationalizing, plus or minus square root of 6 over 3. So these are two solutions waiting here. Or n is equal 1 over 4, so x squared is 1 over 4. Take the square root of both sides, plus half and minus half. See, these are the 4 solutions we are waiting for. Let's see another nice, really nice A part. Find the product now. Find the product of all the solutions of each equation. Let's say the first one. X plus 1 to the power 2 over 3 minus x plus 1 to the power 1 over 3 minus 2 is equal to 0. Do you notice something? It looks like quadratic, but it is not quadratic. See the power here, 1 over 3, it's half the power 2 over 3. So I can take all this with x plus 1 here. All this is equal to n. You see the idea? So easy. Once you catch the idea, so let n is equal x plus 1. All this, you take all the x plus 1 to the power 1 over 3. Square it now, both sides. You get n squared is this one here, x plus 1 to the power 2 over 3. You can go slowly now. So simple. Look at the equation here. The simplest quadratic in n. N squared minus n minus 2. Factor it. N is equal to 2 or n is equal to minus 1. Back to x. Remember, back to x. Each time you put n equals 2, we know this is let. So x plus 1 to the power 1/3 is equal to 1 time is equal minus 1. Now we have power 1 over 3, so we say cube both sides. Cube both sides. So x plus 1 is equal to 2 cubed. X will be 7 and minus 2. When you find the product, it's minus 14. No need to check. Why? This is, if you change this to radicals, it will be cube root. So the index here is odd. No need to check. Now we want to take a minute to try the second one. We have cube root of x plus 1 all squared minus cube root of x plus 1 is equal to 2. If you look closely, I think you notice something. That this equation is exactly this equation. Just exactly, but different form. So let's go to B part. Now we say this is exactly in part A. This equation, exactly the same. So you can use the solution, let n, everything. Solution will be 7 and minus 2, and the product will be minus 14. Everything the same, only the shape is different. Let's take another nice one. Find the sum, please. You can pause the video for a minute here and try it. Find the sum of all the solutions of this. X over x plus 2 all squared is equal 5x divided by x plus 2 minus 6. Now let's look at the solution here. We rearrange first. So I bring 5 on the other side with minus 5. And I make a bracket here around the expression x over x plus 2. Plus 6 is equal to 0. Now let u, you can use, as I said, n or y or k, whatever. I use the let u is equal this fraction here, x over x plus 2. Then u squared minus 5u plus 6 is equal to 0. So this is a quadratic equation in u. This is quadratic in u. Now we can factor it easily. U minus 2, u minus 3. So we have u is equal to 2 or u is equal to 3. Remember, we have to go back to x. Now u is equal to 2. We know what is u here, x over x plus 2. So cross multiply, please, and find x. Same thing for u equals to 3. X over x plus 2 is equal to 3. Cross multiply. On the next slide, we can see x will be minus 4 or x will be minus 3. You can check the numbers easily. Now, the last question, do we have to check? Yes. Why? We don't have any radicals here. No squaring both sides, but we have a fraction. If you have a rational here expression or fractions, you have to check. Maybe if the solution here is minus 2, you put it there, it will be 0 in the denominator. But here we have no 0 in the denominator. So the sum here will be minus 7 because minus 4, minus 3, you add them. But suppose we get a solution x equals minus 2, x equals minus 3, you have to check. So minus 2 is rejected, minus 3 is accepted, the sum will be only minus 3. Now, as usual, I will leave some questions, all the exam questions for practice. Look at this, find the product of the solutions of this nice equation polynomial. Now, question number 2. Given the polynomial equation, all this, you see that? Maybe it's not that easy. Find the total number of solutions, just the number, let's say 2 or 3 or 4 or 1 or 0 or 7, whatever. Find the sum of the negative real solutions. So you have to find the solutions, take the real, take the negative, add them. Nice answer there. Solve the equation for x squared in terms of a. See, we have here 4 square roots. You have to do something, square both sides, something, until you solve for x squared equals something. Find the number of solutions of this equation. 2x is equal to 1 minus square root of 2 minus x. You can try this. And then number 5, find the sum also of all the solutions of this. X plus 2 square root of 3x plus 7 is equal to 1. And then you find the product of all the solutions. There is a nice idea here. I will not say it now. It will be in the next video. So find the product of all the solutions of this equation. This is number 6. And number 7, the sum. So we need here the sum. This is a multiple choice. It's an important question. The sum of all the solutions. This is an equation. Cube root of x minus 1 minus 6th root of x minus 1 is equal to 2. The sum might be 66, 65, 67, 64, 63. Remember the sum. Just find it. Find the product of all the solutions of this equation. For sure you have to factor equal to 0, that one here. And this is question number 9, is a good question. The solutions now, this is an equation, 4x to the power minus 4 minus 16 x to the power minus 2 is equal minus 4. This is also multiple choice, A, B, C, D, E. You have to read carefully. The solution of this equation consists of the solution 2 positive, 2 negative rational numbers, 4 positive irrational numbers, 4 positive rational numbers, 2 positive, 2 negative irrational numbers, 4 negative rational numbers. Please check. Now, I put here, as usual, only the answers here. See the answers for number 1 until 9. Please try them. And if you need the complete solution of this, just see the video after this. Will be called All the Exams Questions, Other Types of Equations. You can find that complete solutions of all these 9 questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is lecture number 24 of the algebra course. I hope I can see you in another video with another topic. Thank you very much and good night.